Assalamu alaikum. My name is Mukhtar Muhammad Chess. My matric number 186456. My supervisor is Dr. Shakina Binti Jamali. Today I'm going to present my final year project proposal video presentation. My project title is Thermophilic versus Mesophilic Fermentative Biohydrogen Production from Food Waste. So the content of this presentation will be keywords, introduction, problem statement, objectives of the study, scope of the study, literature review, methodology, expected outcomes and hypotheses. So the keywords are thermophilic are organisms that are grown at best in temperature between 45 to 65 degrees Celsius. Mesophilic are organisms that are grown at best in the temperature between 20 to 45 degrees Celsius. And fermentative biohydrogen production is the fermentative conversion of organic substrates into hydrogen. Food waste is the food that's left uneaten. So, introduction or the background of this study is the depletion of fossil fuel resources is becoming a global trend. Many studies demonstrate in the next 15 to 20 years, fossil fuels will be used up completely. Therefore, a substitute source of energy is needed. So renewable energy sources have been found as an alternative source of fuels include hydrogen fuel, solar energy, and wind energy. Hydrogen is the ultimate fuel by the reason of its recyclability and eco-friendly nature. Biohydrogen production processes are modern, clean, and low energy consuming while it accommodates the utilization of organic wastes with the generation of good quality fuel. Hydrogen production using conventional physicochemical processes are generally expensive and energy intensive. Therefore, producing hydrogen in a biological way, including dark fermentation, is the most eco-friendly way. Dark fermentation has the ability to produce while converting organic substrates into volatile fatty acids. So, if I summarize real quick, so this is fossil fuel is decreasing, and this is a global issue. So we need alternative energy source. So renewable energy sources are recommended. So the one I will be talking about in this study is the hydrogen. So hydrogen is the ultimate fuel, and hydrogen production methods, physicochemical processes, and so on. So these physicochemical processes are expensive, so I'll be producing hydrogen in the biological way. So biological way is environmentally friendly and it's economic. So the problem statement is food waste is one of the main elements in municipal solid waste in Malaysia. Malaysians dispose up to 930 tons of unconsumed food every day, which has been increasing for the past years. Food waste can be produced. Food waste can be used to produce biofuels and biogas due to its availability in nature and richness in organic matter. This can be attractive for sustainable biohydrogen production due to the wide economic prospects in the industry. The majority of the research of biohydrogen production from food waste has been conducted under dark fermentation. Physicochemical factors such as temperature, thermophilic, and mesophilic are also important to ensure the dominance of hydrogen-producing bacteria in dark fermentation. Therefore, in order to save the environment from the food waste and generate energy at the same time, it's convenient to produce biohydrogen from food waste. So the problem here is the food waste. So food waste is increasing every day, and we need to reduce that problem. So in order to reduce that problem and get energy at the same time, I will be producing hydrogen from food waste. So objectives of the study is that to study the effect of temperature on microbial growth in dark fermentation, and to study the effect of sugar concentration from food waste in hydrogen production or dark fermentation. So the scope of the study is, the experiment of this study was carried out using batch reactor. Food waste was collected from food market in processor tank and blended in the laboratory and then used it as a substrate. Mixed culture sludge was collected from sludge bed semi-derby and then prepared as an inoculant. Dark fermentation is the method that have been chosen by hydrogen production. It can operate without light. So thermophilic temperature, which was 60 degrees Celsius, and mesophilic temperature, which was 30 degrees Celsius, was used in order to study the effect of microbial growth. Different volumes was used to study the effect of sugar concentration from food waste. So the literature review. This is the pathway of hydrogen production. So hydrogen can be produced from fossil fuels. So fossil fuels, the method that have been used is hydrocarbon free-forming or hydrocarbon pyrolysis. And then steam reforming and thermal cracking. So hydrocarbon divided into 4 main sections: steam reforming, partial oxidation, cold gasification, and thermal cracking. So hydrogen can be also produced in a renewable source. So renewable sources can be biomass process, water splitting. So water splitting is thermolysis, photolysis, and electrolysis. So I'll be flowing this path. And biomass process is biological and thermochemical. This is the one I was saying it was expensive and energy intensive. So thermochemical way of producing hydrogen include gasification, combustion, liquefaction, and pyrolysis. And the biological way can be produced in photolysis, photofermentation, and dark fermentation, photo-dark fermentation. So this one will be combined of these two, and dark fermentation will be the method I will be using. So the methodology of this study is preparation. Methodology is divided into 2 main parts, 2 main subdivisions, which are preparation and analysis. So in the preparation, it will be prepared the inoculum preparation and condition medium. And analysis will be the sugar concentration and hydrogen production analysis, yield and productivity. So that will be all. Thank you very much.